So looking at some problems involve and some examples of finding domain and range and the inverse of a function. So 2x is pretty simple. It's a straight line. So the domain of that is all real x, domain of all real y. The inverse, swap the x and y over, so the function then would become a half x. So the inverse is a half x. Again, it's got all real x, all real y. Not too hard. So it's pretty easy, that one. This one, x minus 5, what would be the inverse of this one? Again, swap the x and y's over and then solve. And so it becomes y is equal to x plus 5 is the inverse. Again, domain of the function is all real x, all real y, so it shouldn't be a problem for the inverse function as well. Y is equal to x on 4, the inverse would swap the x and y's over, and y would be 4x. Again, these are all just straight lines, so it's no problem. Their domains and ranges aren't going to be a problem. Again, straight line there. Straight line should give us an inverse function every time as well, so because it's already got a one-to-one correspondence, so it's not a problem. Shouldn't be a problem. X and y swap over. Y would be a third of x minus 2, so that would be the inverse function. Again, the domains and ranges are both all real x, all real y. Again, another straight line. Swap the x and y's and solve. This one's a little bit different. Hyperbola. So y is equal to 1 over x. Swap the x and y's, and we get the inverse function as y equals 1 over x. Okay, domains and ranges, swap around. Not a problem. Like all real x there, all real y, except the x is equal to 1 and equal to 0, so y would not be equal to 0, and these ones will swap over as well. That's not a problem. What you should start to notice is that, wait on, that's the same function. We'll talk more about this, the hyperbola, and being an inverse function of itself later on. The extension 2 kids, we've talked about this one when we were looking at some stuff on polynomials. So y is the inverse function 1 over x, or is 1 over x. So, and when we draw the graph up, you'll be able to get a good understanding of why that would be the case. But that's an interesting one that stays the same. Again, another straight line. So, and it's just being careful with all this algebraic manipulation. Domains and ranges, not a problem there. This one's a little bit different. The cubic, domain all real x, range all real y. So we swap the domains and ranges over, and that would be okay. That would give us a half x to the power of a third, or a half of the cube root of x. So again, just be careful with all your algebra. 2 lots of the square root of x plus 5. Now, the domain here would be x is greater than 0, because you've got to have x is greater than 0. Can't have a negative number put in there. And the smallest value that would get then would be 0, so it's going to be 5 or more. So the inverse function, swap the x and y over, and then we start to calculate for y. So we get x minus 5, we take half, and then we square both sides, which gives us the y equals to a half squared is a quarter, and the x minus 5 is equal to half. So the domain, what are we going to get here? So what we know of is again, we can going to get the x is going to be greater than or equal to 5, because we can see that in the situation there. Now, because it's going to be 5 or more, it's going to be 0. So we can see that that's going to be x. Now, what we've got to do is swap these over. Now, you're probably looking going, wait on, x can be any value. Now, the only problem is that what we've got to do is have a domain where it will give us an inverse function. So we're going to look at this more when we do the graphs, but domain and range needs a swap over there when we look at this one. If we're going to take that as a function and take the inverse, it's only going to be, it's going to look like part of this, but it's got to be restricted. It's got to be restricted there, because that can't go back to that. It's unable to go back to that. So, and we can try and manipulate that, back to that one. Swap the x and y's over again and go back there. Remember, you've got to be able to go back to it and get exactly the same function. That only happens when the domain's restricted in this case, and we'll see with the graphs a bit more. If you're not too sure, wait until we get to the graphs and we can see that. So again, swapping these ones over, this is about the algebraic manipulation in all this. Our domains and range are swapped, and we get the x and y swapping over, and then our algebraic manipulation to get this function as the inverse of that one. E to the power of 2x, so swap e to the power of x and get x to the power of 2y, and swap it over and then solve. So we get 2y equal to log of x, or y is equal to half of log of x. So again, the domain's all real x, so the range becomes all real y, and domains and range swap there. Log of x plus 1, again, what's our domain? This part here has to be greater than 0, so x has to be greater than 1. And we know that range can be all real y, so our domains and ranges will swap over. And we can start to see that this shouldn't be too much of a problem, because we'll get e to the power of x when we swap over first, and then we can manipulate it and get it to this point. Well, there's two different ways to do that. So you take exponential of both sides, or use your definition of a logarithm. Whichever way you want to go, you'll get down to e to the power of x minus 1. So you can see that you can put any value of x in there, and it's going to be greater than minus 1, because the smallest that can be is 1 there. So hopefully we're starting to see the manipulations that we need to take. Now, have a look at this one. This one is interesting, because if we look at y is equal to x squared plus 2, domain's all real x, and range is y is greater than or equal to 2. So you can put any value, we can get any value out as long as it's greater than or equal to 2. So again, our domain here, when we look at it, we can see it when we get our function. We swap our values over. Here we get y squared equal to x minus 2, or the square root of x minus 2, or the square root of x minus 2. So we could get range being all real y, and from the domain of all real x, and x has got to be greater than 2 to get that. Now, if we keep it in either of this form, well, we can see we've got two ways to do it. And if we keep our domain as all real x for our range, and our range is all real y, this is only going to be a relation. And this is what we're going to talk about more later on. Because the only problem is that we get x squared plus 2. So that's x squared plus 2 there. But the square root of x minus 2 would be positive there, negative there. Problem being, that's not a function if we take both of those, or if we can consider that. That's not a function because we get those two values. What we do need is one value. So that's what we need to start to look later on and go, okay, if it's going to be a function, we're going to get an inverse function rather than just an inverse relation. We need to restrict that domain to either that part or that part, so we get either that part or that part. So our range is going to be restricted. But we'll talk more about that in the further videos. And this similar situation, 3x to the power of 4, no problem for the x values. Y is going to be greater than 0. Swap our x and y values around, we get the 4th root of x on 3, or the negative 4th root of x on 3, because either of those can go back to that part. But doing both of those would give us a situation where we don't get a function. So we get a relation if we consider our domain as all real x, and then our range of all real y here for an inverse, but it's an inverse relation, not an inverse function. So part of our task later on will be to look at situations and go, okay, how do I start to restrict it to make sure I get a function? So, and we can talk about, again, remembering our definition of functions, we can go back and work on that later on and make sure we get an inverse function rather than a relation.